share. Right, in the chat side on the right, if you could just type in or let me know verbally if you are having any trouble with the work and want to go over anything in the work that we've already given to you, rationalizing denominators or whatever. If you're having trouble with that, let me know.
So you know when you simplify surds, but it's like to the third root instead of just a square root?
Yep.
How would you do that exactly?
Okay, so let's go over and we'll have a look at this. So simplifying surds to the cubed root, so you had something like this, that the cubed root on the outside or on the inside?
Yeah, on the outside.
Okay, so you know how to do this one. That would just be x square root of xy, because that's x squared x.
Yep.
So this first one can come out. So if we had the cubed root of, give us an example.
24?
24, just like that?
Yeah, something like that.
Okay, is there a square number in 24? So that would be the cubed root of, 8 times 3 is 24. And you can find the cubed root of 8, which would be 2 root 3. So for cubed roots, you're actually looking at your cubic numbers. You're hunting out cubed numbers. So your cubed numbers, 1 cubed, 2 cubed, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is some 343 or something. 49 times 7 is 7 9 is 63, 6, 28, 9, 30, 343. So those are your cubic numbers up to 7 cubed. 8 cubed, I forget what it is, 51 something, 500 and something. So those are your cube numbers. So I look for my cube number of 8 there, and that would take out that outside the bracket. Well, that would be cube root of 3. So it's 2 cube root of 3. Does that make sense?
Yep, all right, that makes sense. Yeah, thanks.
Okay. Anyone else got any questions? No other questions? Okay, I was talking about base 5. Remember, I'm going to try and prove to you that there is a number when it times by itself actually equals -1. So we're talking about base 5 numbers, and I'm going to do 2 numbers, 3 numbers. Which one of these is not base 5? Which one of these is not base 5? 8 is correct, because we can't have anything above 5. We're only using the digits 1, 2, 3, 4, and 0. Okay, so we're going to do some multiplication in base 5 today. Now, we did addition last time, so we're going to do multiplication. So we're going to do 33 times 24 in base 5. So we use base 10 and then we convert it. So 3 4s are 12. 12 is split up to 5 and 5 and 2. So we write our answer as 2, and we carry these 2 lots of 5 over as 2 to our next column. 4 3s are 12, plus the 2 is 14. 14 is made up of 5 and 5 and 4. So we put the 4 down there, and we carry the 2 over to the next column. 4 times nothing is nothing, and 2. So it is 2 4 2 for the first part there. And then we have to do the second line, so multiplying by the 2 with a 0 there. 2 3s are 6. 6 is made up of 5 plus 1. So we put the 1 down here and we carry over a 1 to the next column. 2 3s are 6 and 1 is 7. 7 is made up of 5 plus 2. So we put the 2 down there, carry the 1 lot of 5 over, and add those together. Okay, what happens when we add those together? That's an interesting one. Anyone add those together? We did addition yesterday. What's your answer? No one willing to offer an answer? Have you forgot? Struggling? Have no idea? Type it in. Forgot, struggling, no idea. Or sort of. Hello, is anyone there? Forgot, unsure. Bilal, you're correct. It is 202. We go. 2 plus 0 is 2. 4 plus 1 is 5. 5 is made up of one lot of 5 plus nothing. So we put the 0 down and we carry the 1 of 5 over to there. 2 plus 2 is 4 and 1 is 5. 5 is made up of one lot of 5 plus nothing. So it is 2002 is our answer. Okay, I hope that was a compliment, big brain. We're not criticizing people. We're making positive comments, Celine, aren't we? Okay, shall we do one more multiplication? I want you to know how to multiply in base 5 rather. So I want you to do 123 times 31. I'm going to give you a couple of minutes to do that and see if you can get the answer. Right, I've got an answer worked out. I've done part of it there. The 1, 2, 3 comes from multiplying 1 by each number. That should be easy. You put down your placeholder of 0, which we know how to do. We multiply 3 by 3 is 9. 9 is made up of 5 plus 4. 4, 4, 1, 3. Yes, those who have got 4, 4, 1, 3, you've done well. So what we do is we have, yeah, you're very close, Bilal, that was pretty good. Just a little error there. So we go 3 times 3 is 9. So you put your 4 down and you carry your 1 over to the next column. That's where this 1 comes from. So make sure you carry it over. Then we add those together. Oh, and you do the same. 3 times 2 is 6 and 1 is 7. 7 is made up of 5 plus 2. So you have the 2 there and one lot of 5 gets carried over. And then you go 3 times 1 is 3 and the 1 is 4. Add them together. 4 and 2 is 6. We're not allowed 6. 6 is made up of 5 plus 1. So you put the 1 down and carry a lot of 5 over. 4 ones are 4 and 1 is 5, 6, 7. We know that's made up of 5 plus 2. Oh, hold on. Beg your pardon. Let's go back there. We're just adding up what we're doing. 2, 3, 4. Wasn't multiplying. And then add that 4. 4, 4, 1, 3. Okay. Are we happy with base base 5 then. All good? You understand what I'm doing? 1 and 2. Anyone else? We've got 20 people here. Let's see a few more. If you're not sure, I'll need to go over another example. I want to know if you're not sure. It doesn't matter. We've got some time. You're all on lockdown. Just one more. Yeah, we'll go over one more. So let's make it a little bit longer this time. 3, 1, 3, 2, 4. And we'll times this by, say, 1, 2, 3. So we're going to have several lines of working here. So let's go ahead and do that. I'll give you a few minutes to do that. I like that comment, it's kind of fun.
You finished that? Okay.
No. Just waiting. Well, Celine, I got some of those digits the same, but 2, 6. You've made one carryover error, I think. But I like the 20012 at the end. So that's good, Celine. Anyone else like to offer their answer? Could be. We'll see. We'll go over it now. Right, first I'm going to take this 3 and color code it. 3 fours are 12. 12 is made up of 5 plus 5 plus 2. So we put down the 2. And we're going to carry 2 lots of 5. 3 twos are 6, 7, 8. 8 is made up of 5 plus 3. So we put down the 3 and we carry over 1 lot of 5. 3 threes are 9 and 1 is 10. 10 is made up of 5 plus 5 plus 0. So we put down the 0 and we carry over 2 lots of 5. 3 ones are 3, 4, 5. 5 is made up of 5 plus 0. Put down the 0 and carry over 1 lot of 5. 2 threes are 6 and 1 is 7. 7 is made up of 5 plus 2. Put down the 2, carry over 1 lot of 5. And we get 0 there with a 1 there. 1, 2. See, I made a mistake. So you're probably right, Celine. Already found my one mistake. Okay, so that's the first one done. Now we're going to do everything with the 2 here. So I'll do this in blue. And we start with a placeholder. 2 4s are 8. We know 8 is 5 plus 3. So
Hold on, sir. Over there at the end, when you did like 3 times 3, isn't that 9?
9, yeah.
And then plus 1 is 10?
Yeah. What did I?
Did you do 7?
Maybe.
Or
I probably did. So let's go back and do that. We were doing it in red, weren't we? We go 3 1s are 3, 4 5, 0 carried over 1. Then 3 3s are 9 and 1 is 10. 10 is made up of 5 plus 5 plus 0. And then we carry over the 2. Is that correct? That's better, isn't it? Because 10 is made up of 5 plus 5 plus 0. So we've got to put down this 0 and carry over the 2. So our top line is 20032, not 10032.
okay, I get it.
You happy, Celine, with that as well? Cool. Now let's do the blue one. See, it's easy enough to make mistakes, isn't it? So I'll just get rid of all these carryovers here. So we'll do the one in blue now. 2 times 4 is 8, which is 3, and we carry over 1. 2 2s are 4, and 1 is 5, which we know is 0, and carry over 1 lot of 5. 2 times 3 is 6, and 1 is 7, which we know is 2, and carry over 1 lot of 5. 2 times 1 is 2, and 1 is 3. And 2 times 3 is 6, which is, I'm going to put it over here, 5 plus 1. So we put down the 1 and carry over 1 lot of 5, which there's nothing there. Right. So that's that one. And then the last one is going to be very easy because 0, 0. Just multiply everything by 1. 1 4s are 4, 1 2s are 2, 1 3s are 3, 1 3. So now let's do our adding. This might be a bit challenging. 2. 3 and 3 is 6. We know that 6 is made up of 5 plus 1. So we put our 1 there and carry over 1 unit. 4 and 1 is 5, which is 0. And we carry the 5 over. 2 4 5, which is 0. And carry the 5 over. 3 and 3 is 6 and 1 is 7. So we put down the 2 and carry the 1 over. 1 2 3 4 5, which is 0. And carry the 1 over. 3 4 5, which is 0. And carry the 1 over. Can't have a 5, Celine. Yep, 1 0 0, which was what I actually got on my piece of paper. Cool. So that's multiplication in base 5. We are going to go back a little bit of that next time. This is not examinable, but it is IKR. IKR. What's IKR stand for? I kind of reckon. Oh, I know right. Oh, I know right. I've learned something today. That's good. Okay. Now, we were doing some stuff. Where are we up to? I've forgotten. I set you some work on our maths class. Where is it? Maths. Beg your pardon. Close that. Where are we? Math 3, calc, conics, complex numbers. Right. I've given you some worksheets to do. Radical and power form, those two. Graphing complex numbers, this one here. Were we able to graph complex numbers okay? Yes or no with graphing complex numbers? Oh, I can't see you. So that's what our worksheet was, which I need to see your comments. Okay. Isabel was able to, Bilal not able to graph complex numbers. So let's go over just quickly graphing complex numbers. What I would like to show you, and I can't remember whether I uploaded this or not. I've got a graphic here somewhere. Oh, here it is, rotation, this one here. I want you to look at this right side, this rotation, this animation that I've got. See how things are rotated. You can see how particularly the right one is rotating around. Question, do you see that going, rotating, I can't say clockwise or anti-clockwise. Is it going up or is it going from front to back or is it going from back to front? And now it's swinging both ways for me. Bit of an optical illusion there. But this is rotation in 3D, and I want you to think of your complex numbers as being in three-dimensional. So what we have normally done is we have normally done complex number, we've normally done graphing of things in 2 dimensions. We've normally done that if we've got the point 3, 4, we say this is x and that is y. So we go 1, 2, 3 along the x and 1, 2, 3, 4 along the y. Now, what if I wanted 3, 4, but I want it above the page? Hold on, I'll just get rid of this here. But I want it above the page. I want it 5 high above the page. I can't put I can't lift my pen up and put a dot above that 3 and go 5 high. I can't bring a point out here and go 5 high. So what we could do is we could rotate those axes slightly. So I could make this the x-axis like that, and I could make this the y-axis like that, and I could say, well, this is going to be the height. That's going to be my y-axis. So I could go out 1, 2, 3 on the right. I could go 1, 2, 3, 4 here. So it meets at this point here. But then I'm going to go up 5. 1, 2, 3, 4, 5. So I'm going to take it up 1, 2, 3, 4, 5. And it's 5i there. So this point is directly above this point here. But it's 5 high on the y-axis. That y-axis has moved. Can you see the three-dimensional aspect that I'm trying to get across to you? Yes or no if you understood the three-dimensional aspect? Please, I want some feedback. Did you Celine, yes. Bilal, yes. Isabel, yes, yes. Yes. 5, 6, good, VJ. Any more? Stephen, yes? Cool. Okay, so that little rotation that I put on your thing represents 3 dimensions. So we've got 3 dimensions and one is being rotated. So what I do is I continue rotating that the axis around. So the x-axis is now here. The y-axis is now here. So this is showing the height. And the y-axis is now coming off the page. So I could have it like this. I could have 3, 5. This is the height. And this is the x. And my y-axis is now off the page. And I want it 4 high. But I can't see it. So we ignore that. So we're just doing the 3 to 5. So we've really rotated our axis away. And this is called an Argand plane. And I hope no one asks me why it's called an Argand plane, because the only reason I can tell you is that's how you pronounce Argand, which is not a very good joke. So we eliminate the 3, and we want our I part to be 5. So we go 1, 2, 3, 1, 2, 3, 4, 5, and we put that there is our value, which you might call complex number A. So complex numbers are on an Argand diagram. Hold on, I need to have the, whoops, everything's disappeared. Come back. Here we go, I want this one here. Okay. Complex numbers, they are on an Argand plane or an Argand diagram. And it's just like an X and Y one, except your axes are labeled differently. So I'll do a nice neat one here. Your axes are labeled slightly differently, and they are going to be called your y-axis, draw. So this is your y-axis, and that's your x-axis. So there's no y part to these. So this is how we graph complex numbers. So if you're to graph complex number, say G, and you're given G is 5 plus 3i, then you just go along the x-axis, 1, 2, 3, 4, 5, and up 1, 2, 3, and that's 3 on the y-axis, and that is your complex number. If you are asked to draw it as a vector, so a vector, you start from here and you just draw it here. So that's a vector. Now, once you have a vector there, you have got a right angled triangle. So we have a right angled triangle along here. And we know this triangle is 3 high and it's 5 wide. So we can work out the length of the line. And the length is given the name modulus. You see, you're learning all these new names in calculus. And to do the length, all that we need to do is Pythagoras theory. So it's just the square root of 3 squared plus 5 squared. You're going to use a lot of Pythagoras this year, which is the square root of 9 plus 25, which equals the square root of 34. So that's called the modulus. We can also work out the angle between the x-axis and the complex number, or the ray here. So by using SOHCAHTOA, the 3 is opposite and the 5 is adjacent. So if I go opposite adjacent, SOHCAHTOA, tangent, I want the inverse tangent of opposite 3 divided by adjacent 5. So what's the inverse tangent of 0.6? We need to calculate that on our calculator. $30.96. So the angle is actually 30.96. While I'm here, and are you all still awake? We can then have what we call polar form. Okay, yep, a few people. Polar form, this is really cool, reminds you of the South Pole, is modulus plus angle. So we know the modulus is the square root of 34, and the angle is 30.96. But we've got something in the middle, which is CIS. I'm going to leave it like that today, and I'll explain the CIS at the end. This form over here is called rectangular form. So we're only going to bother with rectangular form today. I will go over this polar form another time. But for those of you who want to find out more, you can have a look at Mr. Chandakay's videos and find that. Okay, so that's your complex numbers on an Argand diagram, just like an X and a Y, but pretend the Y-axis is sticking out and it's going into your face off the page, and you can't see it, you can't write on it. So we just use the X and I part. With that, hopefully, you'll be able to do a little bit of work on, where are we? Close, a little bit of work on this here. Graphing of complex numbers and powers of I. Okay, so let's have a look at this graphing of complex numbers sheet again. And okay, so 6 minus 6i, I would just count along 1, 2, 3, 4, 5, 6, go down 6 there, put a dot. I can't do it on this piece of paper here. So negative 12 plus 15, go along to negative 12 up to 15. Can everyone see where my cursor is? Yes or no? Oh, yes or no, I can't tell. Could someone say yes or no because I can't see the comments?
Yep, everyone's saying yes for sure.
You can see the cursor, good. And negative 9 and negative 6 will be down here. 6 plus 12i. You get the idea, don't you? Very easy to do complex numbers. And so doing it in reverse, if you were to do this in rectangular form, this would be 10 plus 15i. So for number 7, I'd expect to see the answer 10 plus 15i, which it is. So that's pretty easy, that worksheet. So just do a few of those so that you're familiar with it. The answers are there. So I want to make sure that you do that. I want to do the powers of I now, because the powers of I where we need to understand. So if we have I representing the square root of negative 1, I'm just going to say that's by definition now. We haven't proved it yet. We haven't shown that there is a number. But I want you to believe that a number, the square root of negative 1, when we multiply by itself, we call it the number I. So the square root of negative 1 times square root of negative 1 equals I times I, which equals the square roots cancel out, so that becomes negative 1, positive 1, square root of negative 1, add the powers. Yes, we just add the powers. So we've got a half plus a half is the noise stop.
Yeah. What's the address?
1.
1 what?
Albert Road.
Albert.
Yeah.
Yeah.
Sorry.
1 Albert.
So that there is just negative 1 to the power of 1. So doing the square root, you've got the square root of I squared equals the square root of negative 1, and I equals the square root of negative 1. When we do powers of i's, so let's have a look. I to the power of 1 equals negative 1. I to the power of 1, sorry, let's go back there. That's incorrect. I to the power of 1 equals the square root of negative 1. So I to the power of 2 equals negative 1. I to the power of 3 equals negative 1, negative square root of negative 1. And I to the power of 4 equals negative 1 times negative 1, which is positive 1. Okay, I to the power of 5, oops, that's not a power. I to the power of 5 equals I to the power of 4 times I, which equals, we know that I to the power of 4, we can see is 1, and I to the power of 1 is negative, that one there. So we can replace them in there, that is one lot of that. When we go I to the power of 6, it's the same as I to the power of 4 times I squared, which will be negative 1, 1 times negative 1. I to the power of 7 equals I3 times I4, which is going to be 1 times that. And I to the power of 8 is going to be I to the power of 4 times I to the power of 4, which equals positive 1. So there are only 4 answers when you do I to the power of anything. And these are the 4 answers. We could write I cubed as being negative I, because square root of 1 is negative I. And this one here is the same as I. So when we have an even power, it's either negative 1 or positive 1 when we have an even power of I. So even powers of I equal negative 1 or positive 1. Okay? If it's divisible by 4, the even power, it's always going to be positive 1. It's not divisible by 4, it's going to be negative 1. So the worksheet there on powers of I, like if you're asked to find I to the power of 9. So the question there says find I to the power of 9. That's I to the power of 4 times I to the power of 4 times I to the power of 1, which is 1 times 1, which is just I. So that's simplifying the powers down. I to the power of 25, I don't want to type it out, so I know that that's I to the power of 4 times 6, that's 24, times I to the power of 1, that gives me 25. That's 1 times I, which equals I. Okay, class. With that, hopefully, you'll be able to go ahead. I won't give you too much work today. If you could do these ones here, these 2 worksheets, graphing of complex numbers, powers of I, just do those 2. And next week, hopefully we'll be back at school. We can do simplifying complex numbers and continue. Okay, is that all right? If anyone has questions on that lesson, let me know. You can stay back afterwards and get some extra help. Otherwise, you can go and continue those 2 worksheets, finish it off, and have a good evening.
Thank you, Mr.
Thank you. I'll put this lesson up on Google on my sites so you can see it later. Tihan, this is going to be saved in your Google